Welcome back everyone, this is the Trash Panda Dev. In the last video we set up Python and created some sample data to get started. Today we're going to work with real data. We'll learn how to load CSV files, explore what's inside, clean it up, and create meaningful visualizations. This is the workflow you'll use for pretty much every data analysis project, including this one and any other ones you do in the future. As I said, we're going to use the famous Titanic dataset. It has passenger information like age, gender, ticket class, and whether they survived. It's perfect for learning because it has real-world messiness, missing values, different data types, and interesting patterns to discover. So first, you'll go to the kaggle.com dataset. I'll have the link in the description so you guys will be able to download. Just so you guys know and are aware, you will have to create an account for Kaggle, but nothing too crazy. You can uncheck the part where you get emails, so that's perfectly fine. But personally, Kaggle is a great site for data sets, and it doesn't have to be Titanic. It can be anything, and there's many things to learn from as well. But once you create an account or sign in, you'll click here to download. It'll download the file. After that, we'll go to our data analysis project folder, and then you'll drag and drop the Titanic dataset into the data folder. And obviously this is just something that we do. We always want to have our data there. It's just convenient. We know where everything is at, and it's perfect. Next thing we'll do is create a new file, and we'll be making a new notebook. So we'll name it o2 underscore real misspelling, real data exploration, and obviously IP, Y, and B. As always, create a new code cell. Obviously, as we always do, you want to make sure that we import pandas as PD. Next then we do import matplotlib dot there you go dot plyplot as plot. And if you want to do it a lot easier, you could also always just copy and paste here, go here, and then just print it like that. After that, the next step would be reading our CSV file or retrieving our CSV file. So we'll do this by df equals, df just stands for data frame, as I said in the first video, pd read underscore CSV, and then we do parentheses and then quotations, and then after that we go to the directory where the data is at. So we go data slash Titanic. Oh, these are in capitals, so it'll be Titanic data set, and just for good measure, CSV. Perfect, and that's how we retrieve it. After that, what we'll do is do a print statement just to show that we had the data set. So we'll do dataset loaded successfully, and then print. We'll do f quotation shape, and we do shape to retrieve the information, so how many values are in the data set and how many columns. So we'll do shape curly brackets df dot shape, and once we run, data set loaded successfully, and we know that there is 891 items and then 12 columns, so 12 variables. Then the next step, we want to make sure what we're working with, so we'll do this by getting the head, which will print the first 5 rows. So we do this by writing a print statement that just says, you don't have to do the print statement, but it's just nice to be organized. First 5 rows, colon, and then df.head. Always put a parentheses so it prints properly. And as I said earlier, it just prints the first 5 rows. As you can see, we have passenger ID, survived. And survived, as you can see, 0 stands for they didn't survive, 1 stands they did survive. The class, so first class, second class, third class. and then the name of the passenger, their gender, age. Oh, okay. This is siblings and spouse, parents and child, and then tickets, and then the fare for the price, and then the cabin that they're in, and which port did they embarked from. So before we start analyzing, we have to understand what we're working with, and we'll do this by getting the info from the data frame. So we'll do print, or the dataset, dataset info, and then colon, and then just df.info parentheses, and we'll run that. And as you can see, each one has 891 values besides age and cabin. So non-null just means that they're not empty. So for this one, there's 714 of them that are not empty, but we don't know. There's a couple of them missing, and so same thing for cabin. And then for int, just tells us, int64 just tells us that it's a whole number. Object means that it is a text. And then float64 just tells us that it's a number with a decimal. Okay, so for the next step, what we'll do is try to retrieve exactly how many empty cells they are for age and cabin. We'll also retrieve the percentage for empty cells. So we'll do missing values, colon, then we'll create a variable called missing data, and then we'll equal that to df.isnull, parentheses, and then outside the parentheses we do .sum. So what this is doing is getting all the variables that come back as empty and then adding it up together. After that, we'll print. And we'll do missing underscore data, which will show us our data. And then the next part will be, is retrieving the percentage of the missing data. So we'll do print parentheses. We'll do print parentheses, quotations, backslash n as percentages, and then we'll do missing. We'll create another variable named missing percentages, and we'll do this by doing df, which will be the dataset dot is null dot sum, and we'll divide that by the length of the data set, and then multiply that by 100 to get like the percentage number. So this is just doing the number of empty cells divided by 891 times 100. And once we print this, we'll do missing underscore percentages dot round 1, and it just rounded to the 1 decimal place. That's all that does. And once we do shift and enter to run it, ooh, what did I do wrong here? Oh, I forgot the parentheses on these two parts, so don't mind me there. And then once we do shift enter, and I misspelled round. All right, excuse me for that. And once we do shift enter, as you can see, for age we get 177 missing cells, and then for cabin 687, and then embarked 2, and then that's 19.9%, which we would just round up to 20% missing for age, 77% for cabin, and then 0.2% for embarked. After that, we'll retrieve some basic statistics about our numeric columns. So we'll do this by using df.describe, as you remembered from last video. So we'll just do print quote basic stats, and then colon, and we'll just do df.describe parentheses and just click shift enter. And as you remember, it gives us the count, so how many items are in each cell, or how many cells are not empty on each column, and then the mean, the standard deviation, the minimum, the quartiles, and then the max. And as you can see, the average age for the passengers is around 30. Was around 30. It's just 29.69999, so we'll just round it up to 30. And then for the survival rate, it was 38%. So after that, we're going to categorize our data, and we'll look at our text columns. So we'll look at passenger class and count how many people were in each class, then gender distribution, how many were male, how many were female, and then how many people embarked from each station. So we'll do this by doing print passenger. Oh, forgot my quotations. Passenger classes colon, and then under there we'll do print df, and then we'll do brackets to retrieve the class column, and the class column is called p class, so we'll name it exactly that to retrieve it. So we'll do p column dot value underscore counts, and what value counts it does is just counts the amount of unique values and sorts them. So any person that is in first class, it'll count it, and then any person that is in second class, it'll count that, and then third class, so on and so forth. And we'll do the same thing for gender. We'll just copy this to make it easier, and we'll just change what's inside of here, and we'll do \n gender distribution. And here we'll just change the name to retrieve sex, which is for the sex of each passenger. And then the last one should be embarkation ports. So we'll do, and then in here we'll do embarked. And as you can see in here, it matches P class, and if we go higher, it'll match embarked, and it'll also match sex. Perfect. And then once we do, oh, before I forget, we're missing the parentheses here, so just make sure to put parentheses. So it's dot value underscore counts parentheses, and then we'll do shift enter. And as you can see, most people were in third class, so 491. Then second most was first class, and then least most was second class. There were more males than females, and then there were more people coming from Southampton. After that, we're going to deal with the missing ages. So we'll do this by seeing the age distribution. So as you remember last time, we can do plot figure. Inside of figure, we do fig size, so the figure size equals parentheses a 10:6. We do a 10:6 inch plot. Then after that, we do df, and we retrieve age, and the brackets dot hist. Hist just means histogram, and bins. Bins just means the amount of bins slash bars that'll be distributed. So we'll do 30 of them, and then we'll do alpha equals to 0.7. After that, we'll do plot title, and we'll do age distribution of passengers. And then for plot dot X label, we'll name it age. Then the Y label, we'll name it number of passengers. Then we'll show it by doing plot show, then parentheses. At the bottom, we want to show the average age, and we'll do that by using mean. And we will do print parentheses f, then quotations, average age, colon, and in curly brackets we do df, call back the age column, and then outside of the brackets we do dot mean parentheses, and then we'll do colon dot 1f. Then we'll copy the same thing and we'll get the median, and we'll just change the mean part to median, and it should just be the same setup. And as we press shift enter, as you can see, we created a figure, and it has 30 bins. So if you were to count each bar, you'll get 30 of them, and it just distributes each number through there. So as you can see, most people were around 20 years old, maybe like 21, 22, 23. But the average age was 29.7. This should be median age. That's what I should put here. There we go. So shift enter. So the average age was 29.7, and then median age was 28. And since the median and the mean are close, we'll use the median to fill the missing values, since it's less affected by outliers in any way. And now we'll be able to fill the cells properly. So we do this by doing df equals df.fillna, and then parentheses, and then curly brackets, quotations age, then colon df brackets, quotations age dot median, and then parentheses. So what this does, it fills any empty cells with the median. Then for the next part, we'll fill the missing embarked cells, and we'll do this by using the most common value. So we'll do basically the same thing, but we'll copy this, print it here, we'll change this one to embarked, and then same thing with this one, but besides doing median, we'll change this one to mode, and then outside of the parentheses for mode, we'll do brackets 0. Then for the end, we'll just print the missing values after cleaning, and we'll do quotations missing values after cleaning, and then we'll do colon, and then print df.isnull parentheses dot, outside the parentheses we do dot sum parentheses. And then once we do shift enter, as you can see, none of the embarked cells are empty, and none of the age cells are empty, because we filled it up with the median age and then the mode for embarked. Now the only value that is missing, or the missing values, are for cabin, but since there's 77% of them missing, we'll just ignore it, and to be honest, it's not that useful right now. Next, we'll create some new columns that might be useful for analysis. First, we'll start with age group, and to create a new column in the dataset, we can do this by doing df, which calls the dataset, and then we do brackets. Inside the brackets, we'll do quotations and then the name of the new column. So by this, we'll do age group, so that we know it won't go into one of the other columns. And then we'll do equals pd.cut parentheses df brackets age, comma, and then we'll put them in specific bins. So the bins should be equal to, and we'll do brackets because it'll be a list of different bins. So ages between 0 to 18, 18 to 35, let's say, and then 35 to 60, and then 60 to 100. After that, we do comma again, and we'll give labels for each section, and we'll do equals brackets, and same thing, child for the ones that are 0 to 18. Then we should name young adults. Then after that, adult, and then last should be senior. Then we'll create the family size. So we'll do df. This column would be named family size. And we'll do equals df. And we'll retrieve the sibling and spouse section. And by doing that, we do quotations sib spouse, which is that one, and then we also add it to df parent and child, which is just parch. And then we do +1 because we need to also include the person that we're checking. After that, we'll do print age groups colon, and we'll do this by doing print df brackets age underscore group, and then outside the brackets we do values or value underscore counts parentheses, and then for the last one we'll do same thing but for family size, and we'll do family size distribution. And then here we'll just change it to family size. Perfect. And once we do shift enter, as you can see, the most people were in the young adult age group, then adults, then children, then there's only 22 seniors. Then for family size, as you can see, most people went alone, other people went with their partners or maybe a sibling, and then family of 3, 4, so on and so forth. Then after this, we get to the exciting part, which is exploring the main question: what factors influence survival? And we'll do this by creating a plot. First, we'll do plot dot figure fig size equals 12 by 4, and then we'll do plot dot subplot, and then we'll do one row, 2 columns starting at position 1. Then we'll create a variable named survival by class, and we'll make that equal to df.groupby parentheses p class. Oh, we should put that in quotations. P class, and then outside of the parentheses we'll do brackets survived, and then dot mean. Then after that we'll do survival by class dot plot, and then the kind of plot that we'll do will be a bar chart. So we'll do bar, and the color we'll choose, let's say sky blue. So we'll do this by doing quotation sky blue. After that, we'll create a title, plot title, and this will be survival rate by passenger class. Then after that, plot dot y label should be survival rate. Then plot dot x label should be passenger class. Then plot.xticks rotation equals 0. Then the next part we'll do is survival by gender. So we'll do the same thing. And we can just copy and paste most of these. And here we'll do 1 row to 2 columns to starting at position 2. And then we'll retrieve sex and how many people per gender survived, and we'll get the mean of that. After that, we'll do a bar chart, and we'll change the color to light coral. After that, we'll change the title to survival rate by gender. Then the Y label can state as survival rate, but then the X label should be gender. And after that, we'll do plot.tight underscore layout parentheses, and then just plot.show parentheses. And once we do shift enter, okay, we did something wrong here. Oh, I misspelled survival there. So we'll do, there we go. And then since I copied and pasted, I probably did it there as well. And then we do shift enter. And what did we do wrong here? Oh, we didn't write plot. So there we go. Perfect. All right. So now that everything's working, I'll explain a few things real quick. Dot plot kind equals bar just means we're creating a bar chart directly from pandas. And then rotation equals 0 for xticks. Just keeps the x-axis labels horizontal instead of just angling them. It's just an easy way to format it. Then we use groupby. This is a very powerful tool that we can use. It just groups our data by category. So like for P class, it will just group them by the class for each passenger. Then we can calculate the statistics for each group. Here we're calculating the mean for the survival rate for each class and gender. And since survived is equal to 1 and not survived equals to 0, the mean gives us the survival rate. This is very fascinating because, as you can see, first class passengers had a much higher survival rate than the third class. And as you can see for the gender one, since we all know that the Titanic had the women and children first rule, it's clearly applied here and makes sense because mostly women had a higher chance of surviving and not many men. Then one of the other things that we'll do is also see how age affected survival chances. And we'll do this by creating a plot.figure parentheses fig size equals to parentheses 12 by 5. After that, we'll do plot.subplot 1 row 2 columns starting at position 1. Then we'll create a variable named survived, and it'll be equal to df brackets survived to retrieve the survived part. And then we'll do equals 1, so it retrieves any data that is equal to 1 in the survived section. And then we'll check that by age, so we'll do brackets age. Then after that, we'll do same thing, but for people that died. So we'll name a new variable died equal to this, but we change the equals to 0. Then we'll create another histogram, and we'll do plot.hist, then parentheses brackets survived. So we call back the survive variable and then the died variable. Then we do comma bins equals to 30 bins. Then alpha equals to 0.7. Then label equals to survived, and then we do comma and then died. After that, we'll do plot title. I'll just copy and paste this section right here. And the plot title will be age distribution by survival. And then the Y label should be number of passengers. And the X label should be age. Then for the next part, we'll create another graph and we'll do plt.subplot. And we'll do 1, 2, 2. And SNS. And then we'll create a box plot. Inside the box plot, we'll do data equals df. And then we'll do parentheses, not parentheses, comma, x equals age underscore group. And then comma, y equals survived. Then we do plot title equals to survival rate by age group. And then we'll do plot dot y label equal to survive and then 1 equals to yes, and then 0 equals to no. Same thing, we'll just copy this from up here, plot.tie layout, and then plot.show. And once we're ready, we do shift enter. Oh, I misspelled there. Survived. There we go. And then I did the same thing there as well. And once we do shift enter, I misspelled it as well here. Okay. Once we do shift enter, after fixing the problems. So one of the things that I forgot was to add plot legend, and we need to do that. And as you can see, we filter the data by doing df survived equals to 1, so people that survived and by their age, and then people that didn't survive by their age. And then we put it into a histogram, and it creates overlapping histogram with different colors so we can compare them. As you can see, survived is blue and then died is orange. And then for our next part, we were creating a box plot that shows the distribution of people that survived by the age group. But as you can see, it's not appearing correctly, and that's because we didn't calculate the survival rate by the age group first. And to do that, we'll have to change some stuff. So first, we need to change this, and I'll just copy and paste it so it can be easier for you guys. And we'll do this, and this should appear correctly. Okay, so now it's appearing correctly. So what we did differently was we created a variable named survival by age, and then we grouped it by the age group and the people that survived and how many of them survived per age group, and then we got the mean for them. And after that, we put it into the chart, and as you can see, mostly children survived, and they had a 0.5% chance of survival. Young adults had a 0.35. Adults had around a 4.4 chance of surviving, and then seniors had around a 0.25 chance of surviving. Then after that, we'll do a complex analysis. It's not that complex, it's pretty simple. But what we'll do is combine multiple factors to see the full picture, and we'll do this by doing plot figure. I'll just copy and paste this here, and we'll just change the numbers to 10 by 6, and we'll create a heat map. But before we create the heat map, we have to create a variable called survival underscore pivot, and we'll do equals df dot pivot underscore table, and then inside we'll do parentheses values equals quotation survived. Then outside the quotations we do comma index equals quotations p class, then columns equals quotation sex, then we'll do agfunc equals quotations mean. After that, we start creating the heat map by doing sns.heatmap, and then this will be in parentheses, and we'll do survival underscore pivot, then a not equals true. Then after that we'll do fmt equals true, fmt equals quotations dot to f. After that cmap, and this is just the colors for the map, and we'll do red by doing rd, yellow by doing yl, and then green by doing gn. Then we'll do plot title, y label, x label, and then plot show. And by doing that, we can just copy and paste this part here, and we can just rename it by doing survival rate by class and gender. And y label should be passenger class, and x label should be the gender. And then at the end we'll do plot.show, then we'll do print survival rates colon and print survival underscore pivot. We do shift enter. What did I do wrong? I misspelled values, that was all. And then shift enter, and as you can see we have the heat map. This is some pretty advanced stuff. The dot pivot underscore table method just reshapes our data. It's like creating cross tabulation. Then we're looking at survival rates with class as rows and gender as columns, and then the agfunc mean just tells it to calculate the average for each combination. The heat map from Seaborn color codes the values using the CMap red, yellow, green. That's the color map going from red to yellow to green. The not true just puts the actual numbers of each cell, and then the fmt equals to .2f formats them to 2 decimal places. And as you can see, this pretty much tells the whole story. First class women had a 97% chance of surviving, while third class men had a 14% chance of surviving. Your ticket class and your gender were the biggest factors of surviving. As you can see, women that were in first class had a 97% chance of surviving. Then the lower you go, the lower the chances of them surviving. Same thing for men. And as you can see, no matter the class, women had a overwhelmingly higher chance of surviving over men, specifically since there was the women and children first rule on the Titanic. So the things that we accomplished today is we loaded real data from a CSV file. We explored and understood the dataset structure. We identified and handled missing values, created new meaningful columns, discovered insights through visualization. We used advanced techniques like pivot tables and heat maps. This is the exact workflow you'll be using for data analysis in your everyday life or whatever projects or work you may go through. And to save our clean dataset so that we know what to reference back to, we'll just do df.to_csv, and then we'll put a directory of our data folder, and we'll put the name of the new CSV file that we're going to do, and we'll just name it Titanic_clean.csv. We'll do index equals false, and we'll print that our clean data set was saved. So after that, we'll just do this. And as you can see, after you did shift enter, Titanic clean data set appears, and there should be no empty cells, maybe besides for cabin. If this helped you understand real data analysis, hit a like and subscribe. Drop a comment with what data set you'd like to see analyzed next. And if you run into issues, just ask for help. Just write something in the comments and I'm here to help you. And yeah, hope you guys have a great day. Bye bye.